Picture an enchanting celestial symphony led by an endless ensemble of cosmic beings, stars, planets, and satellites, all harmonizing in perfect synchrony. Yet, woven into this astral tapestry is a category of celestial bodies that has long fascinated astronomers: exoplanets. These enigmatic worlds lie beyond our solar system, hidden within the sprawling arms of the Milky Way. Among this seemingly infinite collection of star-bound spheres, one particular exoplanet stands out. A world so strikingly reminiscent of Earth, so eerily familiar, that it may be our planetary counterpart. Enter the realm of Proxima B, a rocky world orbiting our closest stellar neighbor, just 4.2 light-years away. The James Webb Space Telescope, or JWST, is transforming how we explore these distant planets. Envision your thoughts drifting across the grand sweep of the Milky Way, a galaxy that may host over a quadrillion exoplanets. To imagine that scale, picture each exoplanet as a grain of sand. That volume would be enough to fill the Grand Canyon, not just once, but to construct a new version of it, a Grand Canyon 2.0, stretching millions of kilometers across. Even more astonishing, about 20% of these far-off planets are classified as Earth-like based on their geological and atmospheric traits. That means 1 in 5 might harbor conditions similar to those on Earth. But the story doesn't stop with planets alone. Orbiting many of these exoplanets are untold numbers of moons, possibly another quadrillion, each engaged in intricate gravitational dances with their parent worlds. These celestial companions may also hold the potential for life, offering more sites for exploration and wonder. According to Space.com, if you're searching for evidence of life beyond Earth, or even signs of worlds already supporting it, the universe holds limitless potential. Now that we've grasped the overwhelming scale of the cosmos, let's focus on the instrument unlocking its most elusive secrets: the James Webb Space Telescope. Unlike traditional telescopes, the JWST is equipped with a massive 6.5-meter primary mirror, far surpassing Hubble's in size and sensitivity. This mirror, paired with revolutionary infrared sensors and spectrographic instruments, allows the telescope to detect the faintest light from galaxies billions of light-years away, and to peer into the atmospheres of planets orbiting distant stars. More than an observer, the JWST is a scientific laboratory in orbit. Its infrared capabilities allow it to read light signatures from exoplanet atmospheres, dissecting them into spectral components. These light fingerprints reveal a wealth of information: chemical composition, molecular structures, atmospheric pressure, and even the presence of water vapor or carbon-based molecules. In effect, it performs remote biopsies of alien worlds. It is not just an upgraded Hubble, it is a leap in how we understand the cosmos. And among all the exoplanets in JWST's view, one system has garnered particular attention: Proxima B. Discovered in 2016, this world quickly became a focal point of speculation and excitement. Why? First, its proximity. At just 4.2 light-years away, it's the closest potentially habitable exoplanet we've found. To put it in perspective, light from Earth would reach Proxima B in about the same time it takes to complete a college degree or elect 2 U.S. presidents. In cosmic terms, it's practically next door. Yet proximity alone doesn't make it extraordinary. Proxima B lies within its star's habitable zone, the region where temperatures may allow for liquid water to exist. This raises the thrilling possibility of oceans, rivers, and perhaps even weather systems sculpting its surface. Imagine alien waterfalls cascading from unseen cliffs, or tides pulling at distant shores beneath foreign skies. The thought is as haunting as it is beautiful. But Proxima B is not a second Earth in every sense. A single day on Proxima B spans over 11 Earth days. Imagine watching dawn unfold slowly, bathing the landscape in amber hues for hours, followed by a sunset that lingers like an eternal dream. While poetic, this prolonged exposure to light and darkness raises serious questions. Could our biology adapt? How would such rhythms affect our sleep, metabolism, or mental health? What kind of life, if any, could thrive in such conditions? These questions go beyond the realm of imagination. They challenge our assumptions about what makes a planet habitable. The JWST is now our most powerful ally in answering them. By capturing and analyzing the infrared spectra emitted or reflected by Proxima B, it can detect the chemical makeup of its atmosphere. It can determine whether oxygen is present, whether clouds exist, whether there are greenhouse gases, or even signs of industrial pollution. Then, something extraordinary happened. Amid routine observations, scientists using JWST picked up a signal from the direction of Proxima B, not just any signal, an electromagnetic pulse with an unusual structure. It bore patterns, repeating intervals and variations so consistent that they didn't appear random. To many, it hinted at intention. This anomaly sent ripples through the scientific world. Online forums lit up. Some likened it to the famous, "wow" signal of the 1970s. Could this be a deliberate communication? A broadcast? Or perhaps a long-lost signal from a long-dead civilization? Just as mysteriously as it appeared, the signal vanished. No follow-up emissions, no repeated pattern, just a whisper in the void followed by silence. Was it an artificial transmission? A quirk of cosmic noise? Or a hint of something far greater? The mere possibility transformed Proxima B from an astronomical subject into a philosophical riddle. If the signal was artificial, it would imply intelligence, consciousness operating beyond our planet, shaping its world, maybe even watching us. More than that, it would mean we are not alone. But even in the absence of definitive proof, Proxima B has already changed how we view the universe. It is a symbol of hope, a target for exploration, and a mirror reflecting our deepest desires, to know, to connect, and to belong to something larger than ourselves. It invites us not just to gaze outward, but to reflect inward. Our story doesn't end with signals. Researchers are now pursuing even bolder ideas. One of the JWST's most imaginative applications involves searching for artificial illumination, city lights on the night side of distant planets. This effort, once confined to science fiction, is now entering the realm of scientific feasibility. If advanced civilizations exist, they might produce energy detectable by our instruments, infrared signatures from streetlights, industrial zones, or spacefaring structures. Imagine peering into the cosmos and discovering the dim glow of alien cities beneath clouds. The shimmer of synthetic light cutting through a planetary night. That kind of discovery would redefine everything we know, not just about astronomy, but about history, politics, and belief. It would unite us as a species, reminding us that we are not the only storytellers in this vast expanse. Such a revelation would spark urgent questions. How should we communicate? Would we be seen as allies, as students, or as strangers? What technologies, philosophies, or warnings might they share? And perhaps most powerfully, what would we say in return? The James Webb Space Telescope is more than a marvel of engineering. It is an extension of our will to understand, to reach, and to imagine. It peers into realms once thought forever hidden. And in doing so, it whispers back secrets from the stars. So now, as the telescope continues its silent vigil and the cosmos unfolds in unprecedented detail, one thing is clear: the universe is not silent. It hums, pulses, and perhaps, on some deep, resonant level, it speaks. The question is not whether it is trying to communicate. The real question is, are we ready to listen?